The gas giant planets have many moons and thus frequently display eclipses. The most striking involve Jupiter, which has 4 large moons and a low axial tilt, making eclipses more frequent as these bodies pass through the shadow of the larger planet. Transits occur with equal frequency. It is common to see the larger moons casting circular shadows upon Jupiter's cloudtops. The eclipses of the Galilean moons by Jupiter became accurately predictable once their orbital elements were known. During the 1670s, it was discovered that these events were occurring about 17 minutes later than expected when Jupiter was on the far side of the Sun. Ole Romer deduced that the delay was caused by the time needed for light to travel from Jupiter to the Earth. This was used to produce the first estimate of the speed of light. On the other 3 gas giants, Saturn, Uranus and Neptune, eclipses only occur at certain periods during the planet's orbit, due to their higher inclination between the orbits of the Moon and the orbital plane of the planet. The Moon Titan, for example, has an orbital plane tilted about 1.6 degrees to Saturn's equatorial plane, but Saturn has an axial tilt of nearly 27 degrees. The orbital plane of Titan only crosses the line of sight to the Sun at 2 points along Saturn's orbit, as the orbital period of Saturn is 29.7 years. An eclipse is only possible about every 15 years. The timing of the Jovian satellite eclipses was also used to calculate an observer's longitude upon the Earth. By knowing the expected time when an eclipse would be observed at a standard longitude, such as Greenwich, the time difference could be computed by accurately observing the local time of the eclipse. The time difference gives the longitude of the observer because every hour of difference corresponded to 15 degrees around the Earth's equator. This technique was used, for example, by Giovanni di Cassini in 1679 to remap France.